All right. Hello, everyone, and thank you for attending our webinar, XOSTOR Hyperconvergence for XCP-ng, brought to you by Vates and LINBIT. Today, we'll have speakers from both companies presenting. From Vates, CMO Marc-Andre Bizin, and myself will be here. And from LINBIT, CEO Philip Resner. We'll start the webinar by introducing both companies and the LINBIT Vates Alliance, followed by a demonstration of XOSTOR by Mark, the roadmap for the future of XOSTOR, and lastly, a Q&A session. We'll let Mark get started with a quick introduction of Vates.
Thank you, Chris. Thank you. Thanks a lot for your introduction. Don't forget just to cut the sound of the YouTube side to avoid the echo, but that's fine. So hello everyone, and thank you for joining for this webinar session with us. I'm really happy to have Philip with me today. So I guess most of you are probably already familiar with the Vates virtualization management stack. But anyway, I would like to do a very small presentation because I think it's very important for you to understand where we are coming and where we are going, and why this partnership with the folks from LINBIT is very important for Vates, and how it gave birth actually to our hyperconvergent solution, our very own alternative to vSAN, I would say, if you like. So I would like to introduce. In the first place, I would like to introduce a little bit our company. So give me just a few seconds to give you to display what I'm a short presentation. All right, so you should probably see my screen. I'm sorry, I'm working both on the OBS side, the presentation side, and everything, so there is a lot to handle. So let's talk a little bit about Vates. Vates is a company that is specialized really in two different things. We are both specialized into virtualization solution because we are developing XCP-ng hypervisor, let's say virtualization platform, because it's actually more than a simple hypervisor. And we are also developing Xen Orchestra, which is the main appliance, the main interface to administer, manage, and back up your virtual infrastructures. So Vates is a company. I would go quite fast about that because I assume everyone is already knowing us. Most of you are probably knowing us already. So we are a company based in France. We have been created in 2012, and since that time we are developing open source solutions. So we are both specialists of virtualization and open source. When it comes to recognition, Vates is it's a key player in the virtualization market, and we aim to progress. We want to actually create a complete ecosystem. For us, virtualization is not only to provide a solution to administer your virtual machine, it's to provide the whole ecosystem that you might need to administrate your actual infrastructure. So that's what we are good at, that's what we are working, and we are achieving that through open source solution. Everything we do, every solution, every piece of software that we are developing is open source. All the code that we are creating is available on GitHub. We are providing documentation, we are providing everything. But what we want to do is to achieve the best of both worlds, I would say. Our target with Vates virtualization management stack is to provide to have both the philosophy and the accessibility of the open source world, but it's also to provide the ecosystem and the usability that you can find in other closed source solutions existing on the market. And how we do that, how we achieve that through open source is by innovating, the innovation and the partnership. We don't have to systematically reinvent the wheel, because that's the beauty of the open source world. We can work with partners, and that's what we have done for our hyperconvergent solution, because we identified very early that's almost 5 years now we are starting to work with LINBIT around the hyperconvergence that is used currently in XCP-ng, and we don't reinvent everything. We work with partners with amazing projects already existing that are already really powerful, and we integrate that in a fully accessible ecosystem. And that's what we did with LINBIT. That's one of our most prominent partner, I would say, because that's the very first one with which we created a complete solution. It's integrated in the stack, but it's really a part of our solution catalog. It's a completely, I would say, not independent, but almost independent solution compared with what we are doing. But we are doing that on many different aspects as well. And yeah, and before diving into the details of XOSTOR itself, it's important to understand the virtualization stack that we have. That's the whole catalog currently that we have. XCP-ng is a bare metal hypervisor, a real type 1 hypervisor powered by the Xen technology. Xen project is also an open source project. It's under the Linux Foundation, and Vates is part of the Linux Foundation, both the Linux Foundation and the Xen project, and we are contributing or top contributors to the Xen project itself. Xen Orchestra, as I said, is the main interface, and actually it will also be the main interface to install, to deploy, and to monitor any XOSTOR installation that you will have. And in add-on, that are optional product, we have, of course, XOSTOR, which is the last born of the solution we have in our catalog. And it's the HCI solution. It's one of the key aspects of XOSTOR is thanks to this partnership with LINBIT, we have been able to integrate XOSTOR directly into the hypervisor level. So it's not working as other solution might. It's not working at the inside VM on top of Xen on XCP-ng. It's working at the XCP-ng level, which is at the same time, it's more reliable and it gives us better performances. So that's one of the key aspects of XOSTOR as an HCI solution. And we have XOProxy. So XOProxy is basically to delegate backup for infrastructures that are either very large in order to relieve a little bit the load of Xen Orchestra, or located at different geographical emplacement. So yeah, that's it. So the typical infrastructures we can see, including an XOSTOR deployment, might look like this. It's not the only possible option, but it used everything we currently are able to provide with the Vates virtualization management stack. And as I said, XOSTOR is deployed within XCP-ng host. It's not within VM. So before letting the stage to Philip for introducing you the technology which is at the core of XOSTOR hyperconvergence solution, just know that currently XOSTOR is not a frozen project in time. It's not finished. We released the production version of XOSTOR about 1 month ago, but it doesn't mean it's over. It's still a young project. It's still something that we have a roadmap on XOSTOR. We will improve pretty much every aspect of XOSTOR in the future. So we are only at the very beginning of our journey with LINBIT in order to deliver an awesome and cutting-edge hyperconvergence solution. Currently, there is a few requirements in order to deploy XOSTOR. We will come back to it just before showing you how it actually works within Xen Orchestra. But just so you are aware, the current requirements, we have XOSTOR is working starting at least 3 hosts, because we are using a quorum algorithm in order to avoid split brain scenario. This is not something new. Many solutions have the same requirements, so XOSTOR is not an exception. You need at least 3 hosts in order to make it work. It works starting with a single disk. Of course, it may be not the best idea to create hyperconvergence with a single disk. That's not very relevant, but you can start with a single disk on one of the hosts of the pool, and currently you cannot have more than 7 hosts in the cluster or the pool in which you are deploying XOSTOR. In the same spirit, currently, even if it's probably going to happen in the future, it's required to have an internet connection in order to deploy an XOSTOR cluster, because XOSTOR will install packages on your host in order to be able to run, and currently it's not possible to do that in a completely air-gap environment. So XOSTOR, as it is at its current states, require an internet connection for the deployment at least. And finally, it's not an obligation, but it's vastly recommended to have a dedicated 10 gig network interface in order to run XOSTOR. So yeah, so that's it for my very short introduction. And Chris, I leave you the stage again.
Yeah, thank you very much, Mark. And Philip, for those who are unfamiliar, could you please introduce LINBIT and the DRB technology that XOSTR is based on?
Sure. Thank you, Chris. Um, then let's jump right into it. And I'm going to open my slides here. And here we are. So let's go into it. So I'm starting with a few words about the company, about the organization. So we are based out of Austria, so Vienna. So here is our headquarter. Here is about 25 of, of us located in Austria. Then we have about 15 located in the US. And we used to have a physical presence in the US in Portland, Oregon. But since the pandemic, we are a full virtual organization in the US now. So, and we are open source enthusiasts coming from Linux. And we have customers all around the world. And there's one region that is a little bit special, that's Japan, because in Japan, we are represented by exclusive partner there. That's the SIOS group. Okay, so that's enough about the company. Let's dive into the technology. And the low-level part is called DOBD. And what is it? So here in this diagram, this orange box, that is like a Linux kernel. And in the Linux kernel, you have this IO stack. So for many applications, it begins with a file system, buffer cache, and it goes down to the disk scheduler, the disk driver itself, and then the physical storage media. In the context we are talking about today, the virtual machines running on an XCP-ng hypervisor, they will directly access the block devices. So they take this path. And then in this IO stack, there is the DOBD driver inserted. So it's a loadable Linux kernel module. In the context what we are talking today, it's loaded in the DOM0 in the host level. And then what happens from here, whenever a write request comes down the stack, it is sent to the local backing device and is sent over the network all the path to a second storage device, and an acknowledgement travels back all the way. And here, DOBD waits for both acknowledgements to arrive from the local one and the remote one. And if both are there, it signals IO completion to the upper layers. So only then for the virtual machine, this write request is completed. So what I just described is synchronous replication, and that is what you will typically use in a hyperconverged XOSTOR setup. But let me add here, it doesn't stop there. It also supports asynchronous replication. And that, of course, makes a lot of sense if you want to have machines or data centers that are with some distance in between, like a few kilometers to half a continent. Okay, and with that replication, we can keep your data also available also in presence of any disasters like node failures, like storage device failures. And let me add here, in case you have here a VM running and let's say this SSD here is failing, that doesn't mean that the VM has to be moved immediately. What that means is that DOBD will recognize, oh, I receive IO errors from this storage device, from this SSD, and it will then reissue the IOs only to the remote storage media. So that means any read requests now go over the network. The data is read from the SSD on this end, sent, travels all the way back, and arrives at the virtual machine. So it's completely transparent for a virtual machine. It's the actual failure is masked. On the other hand, if the remote node goes away, right, it just stops mirroring. It writes and reads from the local storage media. And what it internally does in addition is it tracks all the changes it does while the remote is away. And when the remote comes back at a later point in time, it knows which blocks were changed in the meantime, and it will do a resynchronization. So let's dive deeper into it. So DLBD is represented on the Linux level as a virtual block device. So you will find it in def DLBD something. And in the moment you open it for read or write, so in another system that might be the mount command. In a XCP-ng context, that is usually the moment you start the virtual machine, right? Then the Xen IO helper tasks will open the device, and in the moment it's opened, it changes its role. It goes into primary role. And from there on, it knows where to replicate to. And if you try to open it here on this machine at the same time, the open will fail. So it allows you only to open it on one side at a time, with only one tiny exception. If you do a live migration, then it's opened on both sides concurrently, but only for a very short time, for the time it takes to execute the live migration. DLBD can handle multiple volumes in a single resource. That might be interesting if you have different physical storage types. Let's say you have super fast NVMe drives and a rather slow RAID 5, and then you have an application that is going to use both storage types. Let's assume it's a database and you have to write ahead logs on the fast device and the table spaces on the slow devices. And in such a setup, you would need to replicate them together, right? So you need to make sure that in the replication stream, never a write to the table spaces can overtake a write to the log area. So DLBD can do that. It's the multi-volume feature, and it supports up to thousands of volumes in a single resource. And it's not a two-node technology. It can mirror from one primary to multiple secondaries concurrently, and that's important. The upper limit is 32, but you won't have 32 replicas of your block data. What we see in real life is either 2 replicas, 3 replicas. In some cases, it makes sense to have 4, 5, 6 if it's distributed over multiple data centers, etc. But nobody does 32. 32 is just a theoretical maximum. And we're talking here about a single volume, a single DLBD resource. And another important feature to mention is that it also supports what we call diskless nodes. You can think of it like it's like an iSCSI initiator that's connected not to one iSCSI target, but to 2 concurrently. And so what it does, every write that comes down is sent to both concurrently. If it gets a read, it load balances the reads. So it sends one read here and the next one here and so on. And again, if one of the node fails, let's say we have a read that was dispatched to the server here on the bottom. Now the server fails before it answers it. Then this node will reissue the read to this machine. It gets the data. The virtual machine gets the requested data. So failure is completely hidden from the virtual machines. In case this machine returns, it's automatically reintegrated. So there will be a background resynchronization. And when that is finished, it's available for reads again. Yes, I think that's the important things to tell you about DBD. Maybe to mention, we always have 3 nodes in the context with XCP-ng, and you can create your volume group with a replica count of 2, and it will always add a third node. It is then a diskless third node to each resource, and that is that it can enable the quorum mechanism, which is very important because that avoids possible split brain situations and data divergence and so on. And so far, I was talking about the lowest component in the stack, the lowest level component in the stack, DBD that sits in the Linux kernel. Now, LINSTOR is like the orchestration around it. And let me explain it by an example. So let's say we have a cluster of 6 nodes. So 6 XCP-ng nodes, and every node contains storage devices. So let's say built-in NVMe drives, right? And what LINSTOR will do for you is it puts a LVM volume group on top of the storage devices. And when now a request for new virtual volumes comes in from XCP-ng or Xen Orchestra, I'm not sure which component sends this request, then LINSTOR, first of all, LINSTOR knows on which node the VM will start. So it tries to create one logic volume on the node where the VM will run, and it will create a second logic volume on another node. I'm assuming here that the resource group has a replication count of 2. In case it has 3, it would create 3 replicas, right? So the small hexagon here is the data volume. And with co-locating one of the replicas with the VM itself, you have 2 advantages. One is any read requests within the VM can be fulfilled by reading from the local replica. So we don't add network latency to the read latency, and we don't create network traffic. So it keeps your switch relaxed. And yes, and the second VM here in my example has the same co-location feature. So one of the replicas is co-located with the workload itself. Now, it's not always as nice as that. So you could live migrate a guest, a virtual machine. And live migration is executed like immediately. And these storage volumes might be huge, right? So after it's live migrated, LINSTOR reconfigures DBD on the fly, and this becomes a 3-node DBD resource, which has a disk list, which operates diskless on this machine, and secondary with a backing disk on these 2 machines. And yes, and now all the reads are executed by shipping the read request to one of the other nodes. And that might be fine, or you can place a policy in LINSTOR saying oh, if a primary is running without local replica for more than, let's say, 1 hour or 1 day, you can define that time period. LINSTOR should try to relocate the storage to the workload. And that means it will check if in this volume group is enough space to create logic volume. And if yes, it creates here this new logic volume. It reconfigures DUBD to replicate to this LV as well. So that means all the data comes from these two nodes shipped and is written to this replica. And when the process is finished, the third copy is removed because I'm assuming we're working here with a resource group that wants to have 2 copies and not 3. And so now it's back in its preferred state for a hyperconverged system. It has the VM and 1 replica co-located. Yes, so this is the quick flyover how LINSTOR works in combination with DUBD. And I hope you will have a lot of interesting questions afterwards. But before we come to the questions, I have here one more slide, or maybe another one. But this slide shows the LINSTOR architecture, so which software components are involved. And on the LINSTOR side, we have one controller process, so LINSTOR controller. And you can see here are 2 like shadows of it. So the LINSTOR controller runs only on 1 machine in your cluster, but it can fail over to other machines. And that is all set up on your Xen cluster after installing it, so that happens automatically. And then on each and every node, you have a LINSTOR satellite process running. So the LINSTOR satellite process, that is completely stateless and configurationless. So everything, what happens is this process is started. So you can view it as like a node agent for the LINSTOR system. And the controller, that has a small database where it keeps track of all the objects. And the controller connects to the satellites and tell them what to do, which logic volume to create, which DUBD config file to put where, and which DUBD command to run. And on top of that, the controller has a REST API, and we have a CLI program to access the REST API. You can inspect everything, and through this REST API, also the Xen Orchestra connects. So I'm not entirely sure, maybe I made here a mistake. It should be the Xen Orchestra, not the hypervisor, right? And yeah, so this structure, that's the, let's call it the control path. And the data path, that is always directly between the nodes. And yeah, and the 2 components, the data path and the control path, they are very well separated. So what I mean with that is you could even upgrade LINSTOR and DUBD independently from each other. But maybe this is only a theoretical thing, since I'm sure Vates will manage all these update procedures for you in this context. Yeah, so maybe to add it, LINSTOR is also available for other platforms, but today XCP-ng is, of course, in the focus. Yes, okay, this is the final slide. So just a few of the many customers we serve. Okay, with that, thank you for listening to my presentation. And now I hope that we get a few questions. So back to you, Chris.
Yeah, thank you very much. So we'll be doing the questions at the end, but if you have them, you can put them in the chat. We'll save them for later. For both you and Mark now, XOSTOR's been in, or the alliance between Vates and LINBIT has been in duration for 4 years now. What has that process been like making XOSTOR? And is it safe to say we're a little relieved now that XOSTOR's been released?
Do you want to start, Philippe, on your side? Or I can take the question if you like.
Yeah,
basically,
let's go.
it has been a long journey for Vates and LINBIT to work together on the XOSTOR implementation, because it was not only to make XOSTOR, but make LINSTOR and DRBD compatible at the XCP-ng level. It was also to create all the interface and the connection and the glue that would work in the context of XCP-ng and use that through Xen Orchestra. By the way, I think that we should jump maybe into what XOSTOR actually looks like. So basically, what Philippe explained in the theoretical aspect, what it looks like in the context of Xen Orchestra and how you deploy it. So I have a few video we made to introduce the main aspect of XOSTOR that I would like to share with you today. So I will swap, it will be like a black screen for maybe a few seconds before the video to start. Yeah, and there we are. So I will comment it in live. So basically, here is how to deploy XOSTOR. And to deploy XOSTOR, you can notice that on the left side of the screen, there is an XOSTOR dedicated panel in the menu. You can find XOSTOR. So you will have to define both the name and the description of your storage repository. And at this stage, you will have to decide the replication strategy that you want to apply for your cluster, for your pool, for your hyperconvergence installation. The replication, you have to note that if you're picking a higher replication level, each time you're increasing the replication, you're actually reducing the amount of total space that you have available, because obviously it means that each data will be replicated a certain number of time depending on your strategy. It's also at this stage that you will have to define if you want a thin or thick provision storage. So obviously, we don't see, at least at Vates, we don't see a real application in which you would like to choose a thick provisioned installation, but it's definitely possible, and there is probably use case that I don't know that would require thick installation version of it. Once you have decided which kind of replication strategy and the provisioning of your storage repository, you will have to choose the pool in which you want to deploy actually the LINSTOR package. So note that it will install on each host. You will have to install the LINSTOR packages that are designed specifically to be compatible with XCP-ng. And you will have the capabilities, once you have decided the pool, you will have on each host, as Philippe said, you have the ability not only you choose the pool, the host and the disk on each host that you want to use for that XOSTOR deployment, but not only you can select multiple disks on a single host, but you can also decide to have some host without any disk in a diskless state. Of course, it's recommended to have an homogeneous installation. So if you have the same type of HDD or SSD would be recommended in order to not bottleneck your own performances with the lowest performance disk. And you simply have a recap at the end that explains everything, an approximate calculation of the storage capacity depending on the replication strategy that you have. And note that at this stage, when you're creating, the first time it will install the tool stack, it will install LINSTOR, and that will require those hosts to be restarted. So there will be a reboot. You have to know that. If you have also on the purely, let's say commercially speaking, that's also doing that. You will have the ability to deploy a trial version of XOSTOR. Basically, if you don't have licenses at this stage for XOSTOR that are available to be deployed on the host that are in the selected pool, it will automatically grant you a trial period for XOSTOR that will help you to try it. So feel free to test the solution in your own infrastructures. if you want to do a POC, you will need to have 3 available hosts. And I think I'm not mistaken. I think the trial is 30 days long. So after that, you can migrate your installation to production if you like. But it's already a good way to test the solution itself. You don't have to do anything really special. It will automatically grant you a trial if you try to deploy an XOSTOR installation without any license available. So there is a reboot at this stage. So now that we have XOSTOR storage repository, everything will be monitored and handled not from the XOSTOR menu, which is mainly there for the deployment. It will be handled from the XOSTOR view into the storage of your pool, into the storage view of the pool. So in there, you will have access to the XOSTOR volume, and you will have multiple information that are displayed. As Philip said, there is always a replication of 2 replication of the database. So that's why you can see there that there is 3 volumes that are linked to the database, and that's inconsistent. I mean, it's not related to the strategy, the replication strategy that you have choose. It will be always the same replication of the database, and it will be always the same thing as well for the state file, if I'm not mistaken. Renan, I'm speaking under your supervision. Among other important information you will have, you will know if the node status, if it's online or not, if it's offline, and you will see if it's in use. Basically, if the volume is open by one host, it cannot be accessed, it cannot be written on by another host. So you can see that where on which host the volume is in use, and as well, and also the disk state. So if there is no discrepancies between the data, if the data are consistent between and across the disk of the replicated storage. So basically, so you will have a complete view. You will see all the volume, and here we can see that the replication, there is two version of the data. So it means the replication is 2, I guess. For other action you would like to handle, we have a small the capability to copy the UID. And what is happening there? What we would show that if there is something happening with the controller, with anything, if something crashing, the system will automatically reallocate the usage of the disk space to another host. So here, what we did is to we purposely stopped the LINSTOR controller in order to basically crash the system, and you will see that the usage of the volume will be reallocated automatically. So it's visible, of course, in the command line. So you can see there that the status, the in-use state has been swapped from one host to the other, from one volume to the other. And on XOSTOR side, we'll have to refresh. It will be, by the way, it will be refreshed automatically. But if you want to refresh it, forcefully refresh, you can just refresh the page, and you can see that the usage has swapped from one to the other. So that's pretty much it for how it's working currently into Xen Orchestra. And we have many things that are coming in the futures, but it's quite simple actually to deploy XOSTOR. You don't have a lot to handle. All the installation, the management of the XOSTOR pool, and so on, that will be automatically handled by the work we have done with LINBIT to make it compatible directly with XCP-ng. The only thing you will have to decide is the replication strategy, the type of storage you want to use, and this kind of stuff. So yeah, that's quite it for the demonstration, I think. So Chris, up to you again.
Yeah, thank you very much, Mark. So one thing you touched on is this is version 1 of XOSTOR, and it's a growing tool for Vates VMS. Could you two talk about what the future of XOSTOR looks like, what new features and additions will be coming?
Yeah, of course. So, I think we are quite in line with the next step in the roadmap. We already have stuff that are in the pipe, I would say. So I can, Philippe, if you want to dive in first, I'm happy to let you go in, but it's up to you.
I think about the Vates roadmap, you should
Yeah,
speak.
okay, go ahead. I will do it. So one of the key components that we would like to improve, and that is already in the roadmap, is the monitoring and the L view of XOSTOR itself. So we would like it to be to have a dedicated. We would probably have a dedicated view into Xen Orchestra that will allow you to display internal errors that are occurring, display invalid states and stuff like that in a dedicated view. So eventually you can not react in case of issue, but actually prevent issue to happen. If you can start to see already that there is error happening in the cluster, you can act before actually an issue is happening. So that's the first big thing in the roadmap, is improving the monitoring and the L view of XOSTOR within Xen Orchestra by collecting information and bringing it up to exposing it into the appliance itself. The second point is to improve the capabilities. I would say that currently you cannot choose a different replication count for a same volume. So what we would like to offer in the future is the capability to decide in a single volume to create specific replication rules for specific volume in the same deployment of XOSTOR. So that's the next big components, the next big steps that we will be working on. And finally, last but not least, probably, we would like to be able to support multiple XOSTOR storage repository within the same pool. So create multiple XOSTOR level. Currently, it's not possible. Once you have selected a pool and created an XOSTOR volume into it, that's it. You cannot create a second XOSTOR storage repository inside of the same pool. In the future, we would like to add this option. And of course, I think there is also continuous improvement. And the more people are joining the XOSTOR community and the XOSTOR users, the more we have feedback, the more we have recommendation, the more we are collecting your requirements, and that will be, of course, a huge part of the future roadmap of XOSTOR. So there, I'm just talking about the thing that we already know that will be done in the future in XOSTOR, but there is many things more that we would like to be defined by the actual usage and the actual requirements of our user. So on your side, Philippe, do you have anything to add to that?
That sounds perfect, and I'm really looking forward to that you have multiple, is it called storage repositories? No. Yeah, so as you know, in computer science, naming is hard. And
yeah, that's true.
And I used in my presentation all the terms, how we use it on the LINSTOR side.
Yeah.
And it's called, on the LINSTOR side, it's called resource group, and I think it maps to a storage repository. No, what's the name?
Roland can maybe help us on that, because maybe
I think that's a good term. Yes, storage repository.
Yeah, storage repository is. How did you say in the LINSTOR?
On the LINSTOR side, we call it a resource group.
Yeah, resource group. Yeah, it's quite the same.
So yes, I'm really looking forward to the moment when multiple resource groups are supported. Each resource group is a one-to-one mapping to a storage repository on the Xen side. Because there are so many tuning knobs possible on the LINSTOR level, and they are attached to this resource group, right? So the most significant one, of course, is the replica count, but there's so many others. Yeah, so let's listen if Chris has other questions waiting for us before I run away with my roadmap.
Yeah, we have a number of questions. Happy to say the first one was already answered, so we'll move on to the next one. If a host is unavailable for any reason and one of your N copies is on a host, does it begin immediately making a new copy on another host to get copies back up to N, or does it have a wait period?
Yeah, so I guess I take the question.
All right.
So yes, that's a configuration value on the LINSTOR side. So this is, we call it property. You could set that property on different levels. So either on the individual resource, so that's like the individual virtual machine, or you can set it on the resource group, so like the storage repository. So I think by default we have there like 60 minutes. I might be wrong, but you can set it from 0, like immediately, to any amount of minutes you want to set it. So I would recommend something like at least 10 minutes, because in case a host just reboots and it comes back in a few minutes, you don't want that, it's evicted from the cluster and the replicas are allocated somewhere else, etc.
Okay, and for the next question, this one's got multiple parts. About disks going down on XOSTOR node, what is the capability to change a disk and reintegrate it in the replication managed by a Linster API or by XOA UI? And should we provide an HBA managed RAID array or independent disks?
Yeah. Then Mark, I start here.
Yeah, okay.
Yeah, so the first part of the question was when a disk fails, right?
Mm-hmm.
When a disk fails, we get I/O errors on the DoBD level, and DoBD immediately kicks the disk out. So the first I/O error we get, we drop the disk. Then LINSTOR sees it, and then the same setting comes into play. If it immediately allocates a new replica somewhere else, or if it waits. And then reintegrating a disk, that really depends, right? If you give it back the same disk or if it's a new disk. Because if it's a new disk, then LINSTOR automatically recreates all the logic volumes, and then you get a full sync of the data to it. And if it's the same disk, yeah, you only get a partial copy to it. I think the second part of the question was how far this is already integrated in the UI.
Yeah, currently that part I can take. Currently, it's not exposed into Xenorchestra. I'm talking under your supervision, Renan, once again, because you're the technical guy there. But currently, it's not exposed in the XUI UI. So you will have actually to go through the LINSTOR API to configure this kind of things and to define the strategy of reintegration and so on. Yeah. And I think the next part of the question was about providing HBA read or not, right? Or independent disk.
Right.
Yeah.
Yeah. Thanks for reminding. Yes. So I usually recommend individual disks because disks today we're talking about NVMe drives, right? And there are barely RAID controllers available that deal with NVMe drives in a way that you get the performance of the NVMe drive. And with this solution, you get replication of the data, so RAID 1. And if you choose 3 copies, right, you always spend 3 times the storage capacity. So in my point of view, it gets too expensive in terms of cost to then have a RAID within the box. So that's the general recommendation. In specific scenarios, there might be other considerations, right?
I think our own recommendation is as well is it's even more. I would say it's part of the requirements for XOSTOR on our side. We tend to say don't do any read that's handled directly by the replication of XOSTOR. So yeah, that's it. Individual disk is the answer there.
All right. For the next question, are there any measurable performance impacts to the host CPU, RAM, XOA CPU, and RAM of using XOSTOR, and what are the typical network throughputs on a 10 GB, assume low latency without any link aggregation? I'm going to put them in the chat here just so you guys have them.
Yeah, thank you. I think Rona maybe come into play on that question.
Yes, I don't have the benchmark in my head, but I can share the blog post with our results and the test using 10 gigabyte network.
Yeah.
I mean, I can add here.
Yeah, thanks.
As I'm in the industry of software-defined storage for quite some time, I can share how we compare to our competitors, right? And in the open source world, competitor number one is Ceph, and we have blog posts on our blog that show that this solution, that LINSTOR DBD uses very little CPU and memory compared to the other solutions out there. And on the other hand, it delivers better performance and lower latency than the other solutions out there. So now you might ask, oh, it's better in every aspect. Is that true? The reason for that is the other solution, Ceph, is like a Swiss Army knife. It does many things. So it is a scissor, it's a knife, and it's a saw. But in all three categories, it's only, well, not the perfect solution. What we do, on the other hand, with LINSTOR and DBD, we are only a block device. So we do only one thing, and we do this as good as possible. So this is why it comes out for this purpose with better performance and lower resource consumption. I hope this explanation makes sense.
Yeah, I'd like to add that part of the fact we decided to integrate LINSTOR directly at the XCP-ng level is also to avoid an extra abstraction level by running this kind of solution. Many solutions out there are working in a VM, like an agent, and that's a new abstraction layer that you have in a VM before going to the hypervisor, before going to the hardware. So running XOSTOR at the hypervisor layer is also a way to improve the performance and to be closer from the hardware performances directly. So yeah, I would say I think we are quite proud of the performances of XOSTOR. We think it runs really well in terms of general performances. But of course, as Philippe also mentioned, that there is many different scenarios, many different infrastructure out there. So benchmark, it's not like a source of truth that you can expect in your infrastructure, because it will depend of your interface, depend of your hardware, it will depend of many different factors. And the only good way to know if it performs well for your infrastructure is actually test the solution, which is doable easily because we are an open source solution as well.
Okay. What does a physical disk failure look like in XO for monitoring tracking down for replacement?
Ronan, please.
Yes. Just know this, the info is not yet implemented in XOA. It's planned maybe in few months. So I must discuss with the XO team about that.
Okay, so it's not currently exposed, and you have to go through the API to actually remove or replace.
In fact, yes, we have an API internally to expose this feature. It's not just used by XO.
So I can add here from the LINSTOR and DBD side, we have SNMP and Prometheus interfaces. So in case you have a monitoring system that either uses SNMP or Prometheus to get a metrics, you can see that information in this monitoring system.
Okay.
Thank you.
In a 3-node scenario, do we have to use a 10 gigabyte switch, or can we connect servers to one another on a 10 gigabyte NIC?
Yes, I take it.
All right.
Yes, you can do that. It will require you a few extra lines of LINSTOR configuration. So, but yeah, it can deal with having 2 point-to-point, well, 3 point-to-point connections between the 3 machines. And
oh, I have that one twice.
Yep.
Next question: Will XO have it? Will XO at least have indication to check underlying system when a physical disk fails, even though we might have to look lower to find and replace it?
I think that the answer would Ronan.
Yeah, it's related to the previous question. Yes.
Yeah. It's related to the previous question. I think it's also a matter of in the roadmap we have the monitoring at LView, and I think that's the things we will try to expose in the future to be able to monitor this kind of situation closely and without having to rely on the API or external monitoring tool. That's thing that will be exposed into the directly into the XOSTOR LView in the future.
Okay, and I think I've got all of our questions. Give it just a second in case I missed anyone and you still wanted to ask something.
Okay, in any case, already, thank you, Philippe, for attending because it was really interesting. It was really interesting to have both the technical view from the DRBD perspective and the implementation. As you probably noticed, I'm not the technical guy in Vates, so I'm seeing that from the interface point of view mainly because that's what I'm understanding the best. But that's really interesting to see how things are actually happening into or translating from the interface to the technology behind it and underneath, under the hood.
We had another one sneak in here. Is there any way to throttle XOSTOR traffic?
Ronan, maybe, do you have any hint on that?
Not really. Maybe for Philippe.
let me think for a second. What we have on the LINSTOR side is to guarantee I/O bandwidth for individual resources, so for individual guests. In other words, you can make sure that one guest is not, consuming all the I/O bandwidth, and it's based on C groups, so it uses this method that you define what's minimal available to this guest, and if nobody else consumes something, he can borrow from the others, right? But if 2 guests want to do I/O as fast as possible, they will only get what is minimum guaranteed to them. But again, if you want to use that, you will need to use the LINSTOR CLI at the moment. There is so much complexity to express through the GUI.
We have an addition to that question here. My bandwidth throttle question was more related to giving replication traffic maximum.
Mm-hmm. Yeah. We don't have knobs for that in LINSTOR because honestly, usually the question is the other way around. I want to have this many IOPS and my network need to be there for that. But on Linux level, right, there is the TC tool, traffic control. And since you have DRBD on well-known ports, you could use the TC tool to create classes of traffic and limit the DRBD traffic, etc. But that's currently outside the scope of LINSTOR.
Okay, and that's the end of our questions. It was a pleasure having anybody. Mark, Philip, do we have anything else we'd like to add at the end?
For me, we think we covered it pretty much everything. So yeah, thank you everyone for attending. That was one of our first webinar there. So we hope to have way more in the futures. And I know for sure, because I participated in some of that, LINBIT is also organizing regular community call. That's really cool. So stay tuned to both our channel, Vates channel and LINBIT channel, to be kept in touch with all the innovation, all the stuff that we are going in both our solution jointly or independently, because yeah, we're working together, but not only. So LINBIT is a very versatile tool as well. LINSTOR is a very versatile tool as well. So thank you everyone for attending, and we will have more to say. We will be Vates will be in live again, but it will be Oliver at the end of the week for the next Xen Orchestra release. So yeah, thank you a lot for attending this session, and see you soon, I guess. Thank you, Philippe, for attending, and thank you, Ronan, for being there.
Me.
See you. See you, everyone, and bye-bye. See you next time.
Thank you.